Hey, this is Mr. Roche. We were working on Mergesort and we were actually working on recursion. I'm gonna try to supplement a little bit of the recursion idea with some stuff so you can see what's going on. But we wanted to also fix our recursion because in Mergesort we had a problem. We were getting a kind of a Stack Overflow error, which means that we're calling and calling and calling our routine and we're not ending the recursion, which is bad. So this is what you want to do when you make a recursive thing. You want to test the recursion absolutely every time before you get started. I think our problem has to do with where we're setting up our midpoint, like the cutting of the list. And I don't know, I was just looking over some stuff, and I think there's just a flat out simpler way to do it from what we were doing it. So let's do this. I'm gonna start and make a new recursive merge. Okay. So we have this thing called RM, and I'm going to make a public void RM new. Okay, and it's still going to take a start and op and and end. Okay, so what happens is you send it part of the list, and it will do the recursion on it. Okay, and that's what we're looking to do. Okay, okay. So basically, it's pretty straightforward. I mean, basically, as long as the start and the end aren't the same, um, we're gonna cut the list, and it's gonna do the recursion. Okay, but let me see. One thing I want to do too is just look at the list so you can kind of see what's going on. Okay, so um, I might do something like this. So we can kind of look at what's going on with the list. Okay. Okay. I like to look at things as much as I can, especially in the beginning. Okay. Let me see. So I got that, and then I'm going to write a for loop. I'm just going to go get a for loop, and I'll just come back and paste it in. So again, this is just something to look at the list. I'll be back. Okay, I'm back, and I have a for loop to print. Okay, I'm going to go from start to end, and I'm just going to print out stuff on the num list. Okay, this doesn't this is just for testing purposes. Okay, we can take this out later. Okay, great. Okay, so that's that. Okay. All right. Then basically all we do is if there's more if the list that you're getting from start to end is bigger than one, we're gonna try to just cut it up, and then we'll merge it later. But basically all we're gonna do is just to check this recursion. We're just gonna do this. Okay. So what we should do really is just I think that maybe somehow we got more complicated in class or something like that, but we just need to simplify. So we're going to say is basically if start is less than end, then we should just try to recurse, okay? Otherwise, the recursion's over, okay? And then what we should say is over 4. And then what we want to do is just find out who this is. And this is like num list of start, okay, or end, whatever, because they should be the same, right? That's the point. Okay, so that's what we're trying to figure out. Okay, inside here we're going to do the recursion. Then one, okay. And then basically what we have to do is we have to find the midpoint, and I think this is where we really kind of messed up. Okay. Okay. So what we still need to do here is we're gonna like basically cut the list with a endpoint. Okay. Divide the list. Okay, this is what we wanted to do. Okay, I'm gonna make a thing called mid. We had middles and stuff like that. Let's make mid, and it's going to equal. I think this is where we got into trouble. I think you say start plus end divided by 2, and I think if you don't do that and you don't include the starting point, then you're not sure on the high end, maybe even on the low end, like where the where the exact midpoint would be. If you just always, we were doing ours always from end, and I think that's where we got in trouble. Okay, and I think all you have to do there is go rm new. Okay, we're gonna recurse, so we're gonna recall rm new, and our start is gonna be from start, to mid. Okay, and then we're gonna go rm new, like mid. This is what we tried to do in the beginning of class, but we just didn't do it. We didn't have this. This wasn't correct. This wasn't correct. Mid plus 1 to n. Okay, and that's going to keep on recursing. Okay, all right. Let me grab a couple of print lines from the thing below from our other old routine, and we'll stick them in here, and then we can watch what happens. Okay, hang on one sec. Back again, and basically what I wanted to do was add a couple of print line statements so we can see what's going on. So this is the old rm new from start to mid. I'm going to say I'm going to cut the list to that, and this is rm new here from mid plus 1 on, and we're going to go like that. Okay, and then basically what happens is this just keeps cutting, and then what's going to happen is basically two adjacent numbers will come back, and what we'll do is we'll merge them and then return that merged list, and then the two will come back and we'll merge that, and everything will sort of work out. But let's not worry about the merge right now. Let's just make sure that we're not getting these you know, these kind of errors and stuff. Okay, so to run this, okay, we have our old rm, but what we've got here is we got our new rm new. Okay, and what we want to do here is go to sort main, and we have you know, everything pretty much commented out. But what we want to do is we want to do this, like not run rm, we're going to run rm new. Okay, so it's like the exact same thing we're going to run for rm new. Okay, I've got 10 in how many? It's an average case thing. Okay, I want to try it out. So I don't know. Let's try to run it with like 4, maybe. Okay, here we go. Let's see what happens. Hopefully it'll work. Okay, no Stack Overflow error, which is good. Okay, let's watch what happened. Okay, so in main we say the number list is 4. Okay, then we send these 4 numbers down to the thing. Okay, it's cutting the list. Okay, so it's 0, 1, 2, 3. It's cutting the list in half. Okay, so it cuts it. It calls rm new again with this. It cuts that down to 640. That's good. Okay. It says the recursion is over for 640, which is great. Okay, keeping going on the other side of that cut, then it has to go to the 482 then. Okay, so it's going to do that. The recursion's over for that one. That's good. Okay, so that whole side, like this whole side now, is now done. So what happens is then the recursion comes down to the other side of the list. Okay, and what's happening here is you have 2, 2. Okay, which would be that. Okay, which is good. So the recursion ends for that, and then it goes to 4 or 2376, and that's it. And it's done it. Okay, and it looks like the split's working okay, just fine actually. Okay, so let's try it. Let's try it for more numbers and see if we don't bomb out. So let's try it for 10 this time. Okay, boom. Here we go. Don't die. Okay, didn't die. That's good. Okay. Looks like it's recursing over everybody. It looks okay. Okay. That seems good. Let's see. Let's go to 100 and see if we die. Okay, did not die. It's going to be hard to check over all of this. But it looks like it gets to 99, 98, 97, 4, 95, 93. Looks like it's getting to everybody pretty well. Okay, looks like it takes like a second half of the list. See how the list gets broken? Like this is this. It takes half of it, keeps trying to do half of it. And then it works with these other halves. And that's cool. That looks good. All right, let's keep going. Let's try 1,000. Okay, good. No errors. Let's go up to 10,000. Okay, still okay. I think we're running into print troubles in a while with these, but that's okay. And let's try 100,000. And it seems to be working. Okay, so that's pretty good. Um, There. Okay, that's fine. No problem. No Stack Overflow problems. So that's good. So as long as we have no Stack Overflow problems, we can add our merge to this. Okay. So this is what we got now. This is a new merge. Okay. Recursive merge. We're using recursion. This is what it looks like. Put it all together. So you can kind of see it. I can put this away. You have one big picture right here. And that is it. Okay, so we're working on this, and we're like learning about recursion, basically. Okay, and recursion's awesome. Okay, it just has to be done carefully, and iterative things will actually run faster. And so what we would like to do is still try to get an iterative version of Mergesort, and we can run it against each other. But that's good. Okay, so it looks pretty good. Let's get this to work. I think our big problem from class was this right here, but we've cleaned that up and we're ready to go. We don't even need to cast convert. We're just going to go right to doing that. Okay, so that's it. Yeah, just make a short video that shows me you have the recursion working. Okay, thanks a lot. Talk to you later.